Hello everyone. So this is Megha here. I am going to teach you organic chemistry. So this is the chapter one. We are going to talk about the introduction part first. Okay. So over here in this whole chapter, we are going to introduce organic chemistry. So for that, let's start with the course. Okay. So first, let's go ahead with the contents. So the contents is introduction, why organic chemistry, unique nature of carbon atoms, types of carbon compounds, hydrocarbons, and conclusion. Okay, we'll study one by one these all concepts. Let's start with the introduction. So introduction, I will tell you a few things about it. So see, organic chemistry when it was like you can take 200 years back when organic chemistry or you can say chemistry was found, then there was a division that was declared for the chemistry, that was two parts. In one division it was called as organic chemistry, the other division was called as inorganic chemistry. So we are not going to learn about inorganic right now, we are going to only learn about organic, but I'll tell you what the inorganic means. So inorganic chemistry is the study of compounds of non-living matter. Okay. And organic means study of compounds of uh, living organisms. Okay. So this uh, definition was first introduced, but later on there was a change when the researchers went across with organic chemistry. They learned many things about it, then they changed the meaning of, or you can say the definition of organic chemistry as the study of compounds of carbon. Okay, you can also say the study of compounds of carbon attached with hydrogen. Okay, so this is the definition. But one more thing I would like to add on out here is something about covalent bond and ionic bond. Okay, so that in later on classes you will be able to understand that very well. So what is ionic bond? First I'll explain that. Ionic bond actually means the bond, that is exchange of electrons. Okay, the chemical reactions in which the elements actually exchange their electrons. Okay, like for example, let's take an example of yeah let's take an example of an element whose electronic configuration is 2 comma 3. So what when they want to form a bond, what they do is they lose that 3 electrons to some to the other element, and then they form the octet formation. Okay, octet formation means in the last cell it should be 8 electrons. That's it. Okay, so what does it do? It removes the 3 electrons from its last cell, and then they form a ionic bond. Okay, if suppose the element is electronic configuration is 2 comma 6. Now in this case what will happen is when it is higher electrons, it is easier to accept than to lose. So what they do is they accept two more electrons from the other element and get combined together, and then ionic bond is formed. Okay, so we are not going to exactly understand about the ionic bond, okay, because we are going to work with covalent bond. Why? Because see, carbon has, before understanding that, we need to understand what is covalent bond. Covalent bond means sharing of electrons. Now if suppose the valence electrons or the last cell electrons are is equal to 4, neither less than 4 nor greater than 4, then what happened in that case? In that case the bond are shared, means the electrons are shared. So that is called covalent bond. We'll learn about it more in detail. Okay, let's proceed further. Why organic chemistry? Now you can see organic chemistry everywhere around you, but you don't know actually. Now see, I can tell you some of the applications of it, like soaps and shampoos, powders and perfumes, food we eat like carbohydrates, proteins, fats, vitamins, these are all organic compounds. Okay, fuels we use like natural gas, petroleum products, etc., medicines, explosives, dyes, insecticides. So you can see that there is a lot of usages of organic chemistry. That is the reason why organic chemistry is brought into picture and is learned by everyone. Okay, let's continue. So unique nature of carbon atoms, there are two unique natures of carbon atoms. First is tetravalency. of carbon atom. Second is catenation. Now we'll understand that in detail. What is tetravalency? That is equivalent to what we were talking about, covalent bonds. Tetravalency means carbon actually has a 6 as its atomic number, and when you check the electronic configuration, it is 2 comma 4. Now you remember 4, neither less than 4 nor greater than 4. So what you can do out here, we can share the electrons. So since its valency is 4 and its valence electrons are 4, that is the reason it is called tetravalency of carbon atom. This is a unique nature of carbon. Okay. The second nature is catenation. Catenation means the tendency to form long chains. How is it done? You'll see later on when we'll discuss about all like the organic chemistry's parts and nomenclature and everything. When we'll go in detail, you'll understand that carbon actually has a tendency to form chains. Okay, it can be very long, like till now 70 carbon atoms can attach to each other and form a compound. Okay, so you can understand 70 carbon atoms, so it is a long chain. Okay, so that is the catenation. Now let's understand types of carbon atoms. Now if you can see out here, see in the page itself it is written, first type of compounds are hydrocarbons. Hydrocarbons means alkane, alkene, alkyne. Now what is alkane, alkene and alkyne? We'll learn this in detail in the other chapters as well, but I'll give you one understanding of it. Hydrocarbons, that is alkane. Alkane means single bond of carbon. Okay, alkene means double bond of carbon. Alkyne means triple bond of carbon. So when alkane is there, the suffix becomes ane. When alkene is there, the suffix becomes ene. And when alkyne is there, the suffix becomes yne. Okay, so we'll understand about the suffix, prefix and the nomenclature also. Over there it will be more clear, but right now just understand, okay, that single bond means alkanes, double bond means alkene, triple bond means alkyne, that is hydrocarbons. Then we have alcohol group as well. So sometimes the carbon hydrogen chain also has OH group. So if it has OH group, it is actually an alcohol group. So a suffix of OL gets attached. Okay, like methanol, ethanol. I'll tell you what is meth, eth, everything I'll tell you about it. But for now, understand that OL will be added. Okay, aldehyde which has CHO group means it is an aldehyde, and Al will be added at the end, like ethanol, methanol. Okay, then we come into ketones. Ketones means a double bond with oxygen, a carbon having a double bond with oxygen, that is a ketone. So over here you can see O and E will be added at the end. Okay, and carboxylic acid, it has a group of COOH group. So what happens is at the end oic acid is added. Okay, ether is C single bond O, C then single bond C. So this group is actually called as ether. So you can call it as a dimethyl ether, diethyl ether, anything like that. Okay, then we'll try to understand halide. Halide means halogens when they actually add up in the CH bonds. So when a halogen is added, like fluorine, chlorine, bromine, iodine, then it is called as like chloroethane, bromoethane, fluoroethane, iodoethane. So in that way, okay. So this is the major, you can say, compounds which we need to understand. Now let's move to the next stage. Now, what are hydrocarbons? Hydrocarbons, like I already told you, alkanes, alkenes, alkynes. But we'll understand the types of hydrocarbons and what is its specialty. So, see, hydrocarbons can be divided into two parts: aliphatic or open chain compounds, cyclic or closed chain compounds. We are not going to study at present about the cyclic or closed chain compounds. We'll first understand the aliphatic or open chain compounds. So, in the open chain compounds, they are saturated and unsaturated uh, compounds. So in the saturated, alkanes is present. Now you must remember that alkanes molecular formula is CnH2n plus 2. Okay, unsaturated carbon has again two parts, alkenes and alkynes. Alkenes molecular formula is CnH2n and alkynes molecular formula is CnH2n minus 2. Okay, now I will give you an example. Okay, let's take that the carbon atom is single. Okay, single carbon atom. So what happens? Let's say there is a single carbon atom, so CN will become 1. Okay, 1 means nothing, so C only. H, 2n plus 2 means 2 ones are 2 plus 2 4, CH4. So what is this called? Methane. Like whenever one single carbon is there, meth is added as a prefix, so it is methane. And why ethane? Because ane is added, it is alkanes. Okay, do you understand that? In that similar way we can understand other things. Okay, so let's again continue. Okay, now it's a conclusion time. So, what we learned today was all the basics of the chemistry, organic chemistry. So, we learned about introduction part of organic chemistry. We also learned some applications and also some things about the hydrocarbons. Okay. So, in the next class, we are going to study about alkyl groups and also the nomenclature. Nomenclature is very important. So, we'll understand the nomenclature also. Okay. Thank you so much for attending the class, and hope you enjoyed, and we'll meet again in the next chapter. Okay, thank you.